perform a lab where we're going to try to verify or determine, I should say, the value of Coulomb's constant. Yesterday, we learned that value of Coulomb's constant should be 8.99 times 10 to the 9 Newton meter squared per coulombs squared. We're going to do a lab today, or a lab simulation today, using data that's presented to us from a website where we're going to try to determine this value. Because that data is cooked up data from an algorithm on a website, we should get a value that is very close, not necessarily exactly, but very close to the accepted value of 8.99 times 10 to the 9. Let me take a few minutes to describe what you're going to do here, okay? First of all, the problem, okay? We want to determine the value of Coulomb's constant. So the problem, always phrased in the form of a question, of course, is what is the value of the experimental value of Coulomb's constant? We're going to have 3 sets of variables, as always, 1 manipulated variable, and that will become very clear to you what that is. At least it should become very clear to you what that is within the next 4 or 5 minutes. There should be 1 responding variable, which also should be very, very clear to you within the next few minutes. And there are, well, technically there's a bazillion control variables, but there are 2 really important control variables that you have to list. They should become also very clear to you in the next few minutes what they are. Probably easier than any other lab we do to identify the control variables in this one. Of course, this is all on Google Classroom for you, so you can write down whatever you need to write down. But just remember that the podcast, as well as the template and as well as the presentation that I'm giving here, is all on Google Classroom, so you can refer back to it. All right, so what are we going to do? You're going to open the app, and there's a link in Google Classroom to that app. You open the app, and then there's a couple of charges that you can set the values of in coulombs. We just want to set them to different values. That's all. Okay, don't worry about what those values are. Just set them to different values. Okay, I don't want your values of charges to be the same as your values of charges to be the same as your values of charges, and I don't want them to be the same values. So if you've got 3 microcoulombs and 6 microcoulombs, that's fine. If you have 4 and 5, that's fine. But you shouldn't have 3 and 3, and you shouldn't have the same as each other. Does that make sense, you guys? So the default, I'm not even sure what the default charges are. Change them and make sure that they're not equal to each other. All right? And then you're going to measure and record, and it's ridiculously simple to measure and to record on a piece of paper what the separation distance is and what the electric force is. You'll see how to record that when you see that app. That's not going to be rocket science at all. You'll see what those values are. There's a ruler where you can physically measure. Now, be careful. Sometimes people mess up using a ruler, right? Especially if it's in between numbers. Be careful with that. Okay? But if you're careful, you should get that. I will tell you guys that if it's easier for you, sometimes people don't notice this, you can actually click and drag the ruler to make it easier to determine the distance between 2 charges. So you're going to measure and record the value of the separation distance between the 2 charges and the resulting electric force, which will be given to you. Then you're going to move a charge. You physically click on the charge and drag it, move it to a new position, or do both of them. I don't care. What you want to do is change the separation distance. And then you're going to see how the force changes in response to changing that separation distance. So move a charge, move both of the charges, whatever. Don't change the values of the charges. Don't change the value of Q1. Don't change the value of Q2. Change the separation distance and see how the force responds to that. And then do it again, and do it again, and do it again, and do it again until you have 10 different values of separation distance and 10 corresponding values of electric force, of attraction or repulsion, doesn't matter what it is. The data table should look something like this. Something like this. Not exactly like this, but something like this. I've missed something. Can anybody tell me, by the way, what I've missed? Units, yeah, I purposely left off the units here. My charge would be measured in coulombs or microcoulombs. When you do a calculation, by the way, if you record your charge in microcoulombs, that's okay to record it whatever units you want, as long as you specify. When you do a calculation, you need to convert to coulombs. My suggestion would be to record the charges in coulombs, and then you don't forget to do that later on, right? But if you do record it in microcoulombs, that can be okay as long as you convert to coulombs before you do your calculations. Now, the separation distance, I believe that the ruler uses centimeters. You can, again, record it in centimeters. But before you do anything with it, what do we want to be in? Meters. So it probably makes sense to record it in meters right off the top, right? But whatever, as long as you convert it to meters at some point before you do your analysis. And electric force, of course, will be in newtons. I've left those off on purpose on your template. This table, by the way, is on your template already. I've left the units off of that because I want you to identify what units you have used. Got it? So what else am I missing besides the units? We need a table title, right? Table 1, colon, so on and so on and so on. You guys, the last couple labs have done an awesome job at titling the table, so I would anticipate that wouldn't be an issue here as well. I can't remember if in the template I've given you a space for the table title. Okay, I can't remember, but if I haven't, that's on you to put a title in there, okay, even if I haven't done that. Okay, your analysis. Well, there's actually a couple of graphs that we're going to plot here. The first graph that we're going to plot is electric force. I'm going to put the symbol in here, but you're going to use words. Okay, so you're going to say electric force and the units, and you're going to say the separation distance. I'm going to use the symbol because it saves me time, but you're going to use words for that. Don't forget to title it. Don't forget to put your initials by the title. When you get this graph, or when you plot this data, you're going to get something that looks like this. Right? We talked about this yesterday, right? The shape that you should get. That's all you got to do with that. You do not need to display an equation with that. We're not mathematically going to touch this graph. It just shows us the relationship between F and R, between F and separation distance. Got it? Okay. Well, I don't want this. I don't want this graph because I can't do a mathematical analysis with it. So watch what I'm going to do. I'm going to plot a new graph. This one is not going to be F versus R. This one is going to be F versus 1 over R squared. So you're literally going to take all your values of R and you're going to square them and then take the inverse. So if I had a value of R of 2.0 meters, my value of 1 over R squared would be 1 over 2 squared, or 0.25. That make sense? And you're going to do that with all of them. The forces aren't going to change, right? The force is still the same as it was in the last column, or the last table. So you can literally just copy and paste that second column into this graph here. Now, don't forget your units here. I will caution you to be careful of the units here. That's a relatively common mistake to mess up on the units for 1 over R squared. Let me give you a hint. It's not meters. The units for R are meters. The units for 1 over R squared is not meters. I'm not going to tell you what it is. That's up to you to think of it, but it's not meters. Okay? Again, relatively common mistake here to put meters for that. All right, then we're going to plot a graph. And the second graph that we're going to plot is force. Again, use words, not symbols. And the x-axis will not be R. It will be 1 over R squared. Or 1 over the separation distance squared in words, right? What shape do you think I'm going to get when I plot this graph? Or what shape do you think I should get when I plot this graph? Y is proportional to X, right? F is proportional to 1 over R squared. Is F proportional to 1 over R squared? Yeah, it's supposed to be. So I should get what shape? Okay. I should get a straight line here, right? And I know how to deal with the straight line, right? I can analyze a straight line. So let's plot your data points. Let's plot your data points. Draw your trend line, or have Google Sheets draw your trend line for you. Display the equation. Remember that R squared value that I told you about? I don't need to see that. I'll tell you what, because this is cooked up data, R squared will be equal to 1. Okay, that's a measurement of how close your data is to the trend line. It better be 1, because this is cooked up data from a website, right? So it has to be 1. That information is useless to us. We want the equation, the y equals mx plus b, equation. I want you to display that equation. Now, what I also want you to do, and you're going to do this for the first time, okay? What I also want you to do is get the equation on your TI calculator, because you might have to do that on your diploma exam. On your diploma exam, you don't have Google Sheets to give us an equation, right? So we need another way to get an equation. Your TI calculator will give you that equation. Let me show you how to do that, okay? We should get the same value for the slope. That's what's going to be important here, is the slope. And your TI calculator should give you the same value for the slope as Google Sheets does. You can compare those. It should be the same value or very, very close to the same value it is. Okay, watch what I'm going to do here, guys. In order to determine the value of the slope and the y-intercept for that matter, although the y-intercept will be irrelevant to us in this one, in order to determine the equation for the graph on your calculator, what we're going to do is the following. It's always the stat. Maybe you guys have done this before. It's going to be stat, edit, 1. Repeat after me. Stat, edit, 1. Stat, edit, 1. So stat, edit, 1, press enter. And then I'm going to enter some data points for this. Now, I cooked up some data points about an hour ago that I'm going to enter into this, okay? Your data points are going to be different, right? My data points, not for R and F, but for 1 over R squared and F. My data points were 1100, 400, 204. These are my X values, right? It's easy to type these in. You can do this with me if you want, just for practice, but in the end, this stage of it you won't have any trouble with. 494, 278, 237, and 178. And then I want to go back and fill in my Y coordinates as well. So my Y coordinates, 319, 115, 58.7, 95.1, 179.8. Again, these are data that I got when I did this lab myself this morning. 460.1. Yours are going to be different, but the process is going to be the same. 142, 79.9, 68.1, and 51.1. So we're going to go stat, edit 1, and then we're going to fill in our data points. Yep. Thank you. That should have been 142. Thank you. I think the rest of them are right. So stat, edit 1, and then just fill in your data points. Easy to fill in your data points. Now let's go stat again. It always starts with stat. Let's scroll over to calc and down to 4, linear regression, AX plus B or MX plus B. Now we're going to press enter. Depending on your version of the calculator, you may have to press enter twice. You may have to press it up to 4 times. Just keep pressing enter until you get the equation spit out for you. I'm going to press enter, enter, keep pressing enter. Look at this. It says y is equal to ax plus b. A is 0.28, so my slope would be 0.28, 0.288, and my y-intercept would be negative 0.2. That make sense? I think I may have actually entered. No, that's okay. Yep. Now, I want you to take a picture with your phone and insert. Take a picture and insert 2 screens from your calculator. I want to see your data table and I want to see your equation. Got it? And it should match the table that you have in your analysis, right? This isn't actually a data table. This is an analysis table, right? Because it's 1 over r squared. That's analysis, not data. R is data. 1 over r squared is analysis. So I want to see your analysis table there, and I want to see your equation displayed. And the slope is going to be what's important here, and that should match up nearly perfectly with the slope that Google Sheets gives us. Got it? Now, what do you do with that slope? Well, what does it represent? How do we find the value of K, Coulomb's constant, with that slope? Let me walk you through this process, or at least walk through this process with you. You guys remember how to analyze a graph, right? We have to have 2 columns. What's the first column? Yep, graph. We need an equation from the graph. And the good news is, whenever you have to do this process, the equation from the graph will always start off the same. What is it? What is the equation for any straight line graph? Y equals mx plus b. Your calculator calls it ax plus b, but same thing, right? Y is equal to mx plus b. Now the good news is the y-intercept here, b, will be small enough that we'll be able to ignore that. So we'll just call it y is equal to mx. Now we're going to replace y with what appears on my x-axis, sorry, my y-axis. That would be f. M stands for, on your calculator, A stands for, in math class, M stands for, Grayson? Somebody said it? Slope of the graph, right? I'm going to write the word slope in there because I don't want to get it mixed up with mass if that ever becomes a problem. My x-axis would be not r, but it would be 1 over r squared. There's the equation that describes this graph. Now, what's my second column? Class. I need an equation from class. Good. So my equation from class that has f and r squared in it, sorry, f and r squared on the bottom. We just did it yesterday, right? What is it? Good. F is equal to k q1 q2 over r squared. What's my next step? Cross off things that appear in both, right? So let's do that. Let's cross off f because it's in both. Let's cross off r squared because it's in both. Oh, we're left with slope now. The slope here is equal to k q1 q2. Good news. I've got the value of the slope. In fact, I've got 2 slopes, right? They should be the same value. Keep the slope either from Google Sheets or from your calculator. It should be the same value. You know what Q1 is. That's the first thing you recorded. You know what Q2 is in coulombs, right? Not microcoulombs, in coulombs. That's the first thing you recorded. Solve for K. And that value of K should be pretty darn close to 8.99 times 10 to the 9. Okay, I'm not going to mark this wrong if you get 9.01 times 10 to the 9, because sometimes there's rounding issues, right? But if you get 8.2 times 10 to the 9, you've made a mistake somewhere. Like you've clearly made a mistake somewhere. Even if you get 8.98 times 10 to the 7, you've made a mistake somewhere. Probably a unit conversion, right? In that case. So you should get very close to 8.99 times 10 to the 9. A little bit of freedom to be off by a little bit on either end of it. But we should have the same order of magnitude, and we shouldn't be like 8.2. 8.97 maybe. Okay, I wouldn't want to be below 8.97. Then your conclusion is just, what's the value of K? Don't forget your units, and then justify that. So in other words, how do you know? In one sentence, how do you know that's your value of K? Where'd you get that from? You don't need to give me the entire analysis again. Just summarize your analysis to tell me where that value of K came from.